So an inverter. An inverter is one of the simplest digital logic gates in terms of function. This gate simply complements the logic input signal. Thus, whatever the input, the output is complemented. So the materials needed are 5 volts power supply, the one that we make in experiment 1, and the breadboard experimenter from experiment 3, and a 1-piece 74LS04 inverter IC, and the hook-up wires or the AWG 22 solid core wires. So here is the breadboard experimenter in the experiment 3, and the 5 volts power supply. This the inverter IC. So let's start by putting a resistor. I used 1k ohm resistor. Alright, so we also need some tools. After that, we put every resistor we put LED lights. So you put the short leg at the ground rail, bottom, so it is in the negatives. And it's done. So this is the resistor and the LED. Next up is we put the IC. So in the IC, at the 14th pin, so this is the 14th pin here, the last one in the left side, and the 7th pin in the last one of the right side. So we connect the 7th pin and in the negative, so in the ground. Okay. Positive in the 14th pin over the VCC. After that, so here it is. We connected the VCC to the positive, the power rail, and the ground to the ground rail. And next is we connect all the LEDs to the IC. So in this experiment, if an input is 1, so two lights are on, and if we on the switch, so the three LEDs will on. So let's start. you're done, then check all the connections. Make sure that it is connected well to the breadboard, and don't attach the other wire. So let's check if the connections are well connected, the wires. So the wires are connected well. So it will be like this. I've arranged it well so that you can see it clear right here. So we're done connecting all the wires to the breadboard. The circuit, there is only one input, so this is the high and low. So I've connected the input in the D3 or in the third switch of the dip switch. So this is this, and when it is connected to the power supply, so the first LED, I've set up that first LED, second and third LED will light up, and if I set the D3 to 1 or a high, so the other LED will turn on and the other will turn off. So this is all for the experiment called the inverter, and using the 7LS04N IC or the inverter IC. And now let's test our experiment. Let's connect the power supply. And the red wire to the positive and the black to the negative. Yeah, so this is it. Basically, the first LED and the fourth LED is on because it is when the D0 set as low, then the first LED, the third LED, fourth LED will turn on, and if I set the D0 to 0, so the second LED and the fifth LED will turn on, and the first, third, fourth LED will turn off. And if I set the D3 to high or 1, so it will turn on. So that's it for our experiment, the inverter. This experiment demonstrated the fundamental operations of the LS04 inverter IC by applying a single output to multiple inverter gates. It was observed that the output consistently produced the logical complement of the input signal. When the input was at logic low, the output went high, turning the LEDs on, and when the input was at logic high, the outputs went low, turning the LEDs off. This confirms that the truth table of the inverter gate in learn something about our experiment and about this video.